back. So what we're looking at today is lesson 7, connecting representations of functions. Let's go ahead and jump right in. All right, so we are comparing functions. Now this graph, can't talk today, probably looks pretty familiar. We just did it in the last one. So the graph shows the temperature between noon and midnight in city A on a certain day. The table shows the temperature T in degrees Fahrenheit for H hours after noon in city B. So we have two different cities. We've got city B, city A, and we've got the time and the temperature after noon in each. Okay, so which city was warmer at 4 p.m.? So at 4 p.m., city B was 62, and at 4 p.m. here, it was only about 57. So city B was warmer. All right, our next one. Which city had a bigger change in temperature between 1 and 5 p.m.? So let's take a look from 1 to 5. And so here we're at about 50.2. At 5, we're all the way up here at 58. So we'll say about 50.2 to 58 degrees. Whereas city B from 1 to 5 went from 82 down to 58. So which is the bigger difference? About 7.8 degrees or a whole lot of degrees? Let's see, 82 minus 58 is 24. City B definitely had the bigger difference. How much greater was the highest recorded temperature in city B than the highest recorded temperature in city A during this time? So highest temperature in city B looks to be our 82 here, and the highest temperature looks to be 59. So 82 minus 59 would give us 23. So a 23 degree difference, approximately, we'll say about, because that 59 was slightly above, but so about 23 degree difference. Compare the outputs of the functions when the input is 3. So if we go up here, input 3, we're at about 54.7 maybe, or 54.5. So function 1 gives us the temperature of city A at 3 p.m., which is about 54.5 degrees. So city B at 3 p.m. was 75 degrees. So city B is definitely hotter than city A at that time. And it's about by 20 degrees because this is almost 55. This is 75. So it's a little, yeah, it's 20.5. So just a little over 20 degree difference. Everything that we just talked about. First function, temp in city A at 3 p.m., which is about 54.5 degrees Fahrenheit. Second function, temp in city B at 3 p.m., which is 75 degrees Fahrenheit. City B is hotter than city A at 3 p.m. by about 20.5 degrees Fahrenheit. All right, the next section, comparing volumes. The volume V of a cube with edge length S is given by the equation V equals S to the third power. The volume of a sphere is a function of its radius in centimeters, and the graph of this relationship is shown here. So this is the sphere's volume shown, and this is the cube for the equation. Is the volume of a cube with edge length S equals 3 greater or less than the volume of sphere with radius 3? So if we look, so this is our first question, sorry. So if we look, radius of 3, we're over 100, probably 115 maybe. So over 100 centimeters cubed. And for the cube, when s is 3, well, if we do 3 to the third, 3 times 3 is 9, times 3 is 27. So the volume for the cube is only 27 centimeters cubed. So the volume of cube is much less. So 27 centimeters cubed, so it is less than the sphere. All right, if a sphere has the same volume as a cube with edge length 5, estimate the radius of the sphere. So the cube, if it has an edge length of 5, we'd take 5 to the third power, which would be 125. So now we want to look for 125 and about where that would be. So that'd be about right here. So probably, let's see, 3.1 approximately. So 3.1 centimeters, thereabouts. All right, and last but not least, compare the outputs of the two volume functions when the inputs are 2. So for the cube, volume equals 2 to the third, so volume equals 8 centimeters cubed. For the sphere, if we look at the graph, put an input of 2, we go up, we're right about there. So we're a little over 25, probably about halfway, so maybe 35-ish. So 35 centimeters cubed. So the sphere has a much larger volume than the cube does when we compare side length and radius as our the values there that we look at having the same and plugging in for our inputs. So lots of comparing here, looking at more than one function or more than one representation of a function, and then being able to determine different things about those. So compare is your key word for this lesson, compare. All right, if you guys have any questions, feel free to